Hello dear students, this is your second video for first chapter of second unit. In last lecture we discussed about concept of point mass and basic classification of motion. So in this lecture we'll continue the discussion. The first point of discussion is the frame of reference. Frame of reference is necessary in physics and it is required for studying motion of an object. As you know that motion is not absolute, motion is relative. We always study motion of an object with respect to some other object. Now what is this other object? This other object is observer, and for studying motion, observer must have to fix a reference point from which the other object is moving so that observer can calculate its position. And second point, in this frame of reference, observer must have a clock with him so that he can know at what time what is the position of the object which he is observing. So the frame of reference is a system of coordinate axes attached to an observer having a clock with him with respect to which the observer can describe position, displacement and acceleration, etc. Frame of reference can be classified in two parts. First, inertial frame of reference, and second, non-inertial frame of reference. What is inertial frame of reference? It is that frame of reference in which Newton's first law holds good. Or in other words, I will give you an example that inertial frame of reference is that frame of reference in which the acceleration of frame itself is zero. Either the frame is stationary or the frame is moving with constant velocity, because if the frame is in acceleration, then all the objects considered in that frame must experience a force in backward direction and which will accelerate them, and we cannot apply Newton's first law in such frame of reference. While non-inertial frame of reference is that it is that frame of reference in which Newton's first law does not holds good. For example, you are sitting in a car and car is accelerating, then you must experience a force in backward direction which you would not have been which would you would not experience that force if you would have been standing on ground. So that means accelerating car is giving you an additional force without any source, that is also known as pseudo force. So any frame of reference which is having acceleration cannot be an inertial frame of reference. Such frame is known as non-inertial frame of reference. Next is scalar versus vector quantities. This is very important as now you are in class 11th and you are studying your physics. Vectors plays very important role in physics and mathematics for class 12th and onward classes. So a scalar is a quantity which has only magnitude. For example, 5 kg rice. So this 5 kg rice has nothing to do with the direction. It is only the magnitude, and the magnitude is the multiplication of numerical value and the unit. Like speed, 20 meter per second, it is scalar. On the other hand, if we are talking about vectors, then the vector have magnitude as well as direction. For example, if you will observe in this graph x and y, and if a car is moving like this with velocity 20 meter per second, then you know that the car is moving in particularly plus x direction, and plus x direction we represent by I and y direction we represent by j. So you can say v is equal to 20 I meter per second. Clearly this I is unit vector and it is representing the direction in which car is moving. So magnitude as well as direction is what known as vector. I'll tell you more about vectors. So how do we represent vector? A vector is generally represented by an arrow geographically, and the length of the arrow represents the magnitude. Suppose 20 unit is the length, then 20 unit it can be centimeter or millimeter, and the direction is arrow tip of the vector is showing the direction. So in vector analysis, a car which is moving with 20 meter per second towards right hand side, suppose the velocity vector is v1, is not equal to a velocity vector in which a car having same magnitude of velocity, that is 20 meter per second, but it is moving in backward direction. So hence you can see that this vector v2 is not is different from vector v1 because their direction is different. So in vectors, direction plays very important role, and also the vectors cannot be added simply like the laws of algebra, 2 plus 2 is equal to 4 or 2 plus 3 is equal to 5. There is different rules for adding vector. We have to take their direction. There is triangle law of vector addition, you will study it ahead. For now you must understand that we are going to use two main two or three main quantities in scalar and vectors. Distance and speed are to be considered as scalar quantities, while velocity, acceleration, and displacement are to be considered as vector quantities. Let's go back to the topic where we left the discussion. Path length and displacement, or we can say distance versus displacement. This is the most basic difference between a scalar and a vector. You must have studied in class 9th. Suppose a person or an object starts from point A and moves 3 meter in upward direction, and then that object turns to right and moves 4 meter. So we know that the actual distance covered by the object is going to be 3 plus 4, 7 meter. So that is the distance traveled by, or you can say the path length which it actually moved. But what is displacement? Displacement is the shortest straight line path between its initial and final position. That is what known as displacement. And displacement is a vector quantity, and in this case you can see here displacement is 5 because it is a right angle triangle, and you can see 3 square plus 4 square square root is equal to square root of 25, and that is equal to 5 meter. So displacement is 5 meter and distance is 3 plus 4, 7 meter. So that is the difference between path length and displacement. I can give you one more example here. Consider an object which starts moving from A and move up to the point B on a semicircle, and suppose the diameter of the circle is 10 meter. Then this is going to be the displacement, and the path length is going to be this semicircular arc, which is equal to pi r. So that is pi into 5 meter. So that pi 2 pi r, we know that is the full circumference, and this pi r, which is half circumference, is the path distance, while 10 meter is the displacement. So that is the difference between distance versus displacement, which we are going to use in our discussion. Next, moving ahead, what is speed? So speed is defined as rate of change of distance, that is speed. So speed, it is defined as rate of change of distance. The formula which we are going to use is s is equal to d divided by t, where d is the distance. There are four types of speed which we will study in this book. That is, first is uniform speed. So uniform speed is when an object which starts moving from a point A and reaches a point B, and it moves with the same speed and it does not change its speed. For example, an object moves between 2 points and moves with 10 meter per second, a constant speed, and does not change its speed between points A and B. Then this type of speed is known as uniform speed, which is constant and is not changing. Then we are having variable speed. Variable speed, as the name is indicating itself, if an object starts from A, move to B with speed 5 meter per second, then it moves from B to C with speed 10 meter per second, and then it moves from C to D at speed 2 meter per second. So you are observing in this example that object is changing its speed. in the distance covered from A to B, the speed was different, 5 meter per second. B to C, it was 10 meter per second. C to D, it was 2 meter per second. So as the speed is changing, that is known as variable speed. If the speed is uniform, it means it is constant. If it is changing, it means variable. What is average speed? Average speed is always calculated as total distance by total time. There are two types of problems which are given for calculating average speed. Like the first is different speeds given for different times and different speeds given for different distance. Let us examine this in detail. Let us consider this example in which an object starts moving from A for 1 hour. It moves with the speed of 40 meter per second and reach at a point B, and then for 1 hour it moves with speed 60 meter per second, and we are interested in calculating average speed. So for calculating average speed, you always remember this formula. Average speed is equal to total distance by total time. So this is the formula which we will use, total distance divided by total time. Here the total distance we can calculate very easily. As you can see, 40 meter per second for 1 hour. So the distance covered is 40 meter per second, and please note the time is given in hours, so we can write 40 into 3600 seconds plus 60 meter per second, and it's in hours, so we can multiply it with 3600 seconds. So that is the total distance divided by total time, and total time we can see is 2 hours. So 2 hours, for 2 hours I can write 2 into 3600 seconds. I can see in this diagram 3600 we can take common from numerator, and 3600 will get cancel out. So I can write like 3600 common 40 plus 60, or divide by 2 into 3600. So 3600 will get cancelled and we'll get a final answer. 50 meter per second is the average speed. So it was a very simple example in which we calculated average speed for an object which moved from A to B with 40 meter per second and B to C with 60 meter per second. Now what can be a second example? I'll tell you. In second example, we'll take an example for equal distances. So again, let us consider an object which is moving with a speed 40 meter per second for first kilometer. Now instead of time, distance is given. So for first kilometer between A to B, the speed of object is 40 meter per second, and then from B to C, the second kilometer, object moves with speed 60 meter per second. So now what will happen? Will average speed again come equal to 50 meter per second, or it will be some different value? So let us check this. We'll again apply our simple formula. Average speed is equal to total distance by total time. This time for calculating average speed, total distance we already know, that is 2 kilometer, because as it is given first kilometer and second kilometer. So I can also write it like 2000 meter divide by, now the total time can be calculated by the formula distance divided by speed. So total time is going to be 1000 meters divided by 40 meter per second, and plus the second kilometer, which is again 1000 meter divided by 60 meter per second. So in this example you can see I can again take 1000 common, and it can get cancelled with 2000 meters above, and I will get here 120 as LCM, 43 ja 120 plus 62 ja, and I am having 2 above, because taking 1000 common will cancel out. In the next step I can write 120 into 2 divided by 5. So 5 2 ja 10, remaining 2, 20, 5 4 ja 20, and I am getting 48 meter per second. Hence this is the average speed, which is final answer for two different speeds if they are given for two different distances rather than for two different times. So I think it is giving you a fairly good idea how to calculate speed. And study the text of the book thoroughly, and do solved examples. And if you are able to solve the problems for practice, try them too. And then I'll see you in next lecture. Thank you.